times, just to warn you. Okay, just to warn you.
I know.
Okay, trigonometry is the study of triangles and angles, and really a beautiful study that connects a lot of those pieces together. You're going to see connections all over the place, and really starting today. It really starts with the whole idea of a squared plus b squared is equal to c squared. What is that? Pythagorean theorem. It applies to right triangles. And from a squared plus b squared equals c squared, we can really develop just about all of trigonometry from that piece. You're going to be amazed at the power behind that one expression. And the first thing that we develop from it is this thing called the unit circle. A unit circle is a circle centered at 0, 0 with a radius of 1. Circle centered at 0, 0 with a radius of 1. Okay. Does everybody remember the formula for the equation of a circle? Don't say pi r squared. This is in section 1.8. You guys tested on it. You did an excellent job. It's x minus h quantity squared plus y minus k quantity squared is equal to r squared. That's the equation for a circle. And so if you say that the center is at 0, 0, and you put 0 in for h and for k, notice that the equation becomes x squared plus y squared. And if the radius is 1, then that is equal to just 1. So the unit circle has the formula x squared plus y squared is equal to 1. What I just asked that you recognize right now is that these two are very, very similar to each other. Agreed? Okay. So the Pythagorean theorem produces the unit circle. Let's see what the unit circle looks like. Here's a picture of the unit circle right here. This is the x-axis. This is the y-axis. Anybody know at what coordinate the circle would intersect right there? Anybody know what that coordinate would be?
1, 0.
1, 0. You will continue to produce this over the course of the entire year, as well as when you take calculus. This is something that stays with you a long time. What would this coordinate be?
0, 1.
Good. Then back here, negative 1, 0. And on the bottom, I have 0, negative 1. There we go. We got those 4. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. The fact is that the unit circle has many points that are on it. An infinite number of points lie on the unit circle. These are 4 that sit at the axes. Okay? And we reference these quite often. Okay? The first question is confirm that the point root of 3 over 2, negative 1/2 is on the unit circle. If you were to convert those to decimals, the square root of 3 divided by 2 is approximately 0.86. And negative 1/2 is negative 0.5. So if you were to plot that, if you were to go over about 0.86 and down 1/2, you get a spot right about there. Okay. So it's in the fourth quadrant. We want to confirm that that's on the unit circle. So we want to show that this thing sits on that circle. So to confirm that, we're just going to plug in the x and the y and see if it satisfies it. So I'll plug in square root of 3 over 2 for x. And I'll plug in negative 1/2 for y. What do you get if you square the root of 3 over 2?
3/4.
3/4. The top you get a 3, and the bottom you get a 4. And if you square negative 1/2, you're going to get positive 1 in the top and 4 in the bottom. Is 3/4 plus 1/4 equal to 1? Absolutely. So you can see that that coordinate does, in fact, sit on the unit circle. Okay. Try another example here. It says point P lies in the third quadrant. So we'll just put point P over here in the third quadrant. it says that the x coordinate of point P is -2/5. But we don't know the y coordinate. Okay, it says find point P. So I know the x value and I know it lies in the third quadrant. Now we're going to try to find the y value. So I will just use my equation for the unit circle. X squared plus y squared is 1. I plug in -2/5 for x. I square that and I get 4/25. And instead of 1, I'm going to write it as 25/25 because I can see that I have now common denominators. I'm going to need to subtract that over. As I subtract, I get y squared is equal to 21/25. And as we solve by taking the square root, notice it's a y squared. Because it's y squared, you're going to have two solutions. So therefore, you need to list both the positive and the negative. So y is equal to plus or minus the square root of 21 is what's on top, and on bottom you just have 5. So what do you think my answer is? Is it positive root of 21/5? Is it negative root of 21/5? Or is it both of them? Why is it the negative?
It's in the third quadrant.
If you're in the third quadrant, the y value must be negative. This is the negative root of 21/5. There's just a little introduction to unit circle. We will not get to an assignment today, but we'll get to a nice introduction to the big piece that we want to talk about, which is degree and radian measure as we look at this unit circle. As we place this unit circle on the x and y axis, you can see here what we like to do is we like to say that this part of the x-axis we like to call 0 degrees. Okay. And as you extend that up, anybody know what we're going to call that spot? We're going to call it 90. Cross to this side, and then down 270, and all the way around 360. Okay. There we have it. Okay. Whenever I see the circles, I always think of pizza. What kind of pizza do you like?
The special from Jake's.
Special from Jake's.
Yeah, I don't really know what's on it. It's got like mushrooms and all.
Okay.
It's kind of fire.
I like a good straight up Canadian bacon. Jackson Richards professed today that he likes to have pineapple on his pizza,
I do too.
which I find to be disappointing. You say it is the best.
Don't Canadian bacon and pineapple normally go together?
I don't like it like pretend world maybe, but not in reality.
For Christmas, my dad got a pizza oven.
Yeah.
We made pizza like multiple nights.
Ooh.
And it was really
Very
good.
good, huh?
Yeah.
Do you throw pineapple on yours?
I like if there's. I will, but it's not like my go-to. Like I'll eat it and I don't mind it.
I think like if you're having a breakfast or a snack in the middle of the day, like you could have some pineapple with that. But like when it comes to my pizza,
I kind of like the.
don't put fruit on my pizza. Okay?
When it's cooked, it's good.
Yeah, like it's kind of sweet too.
Yeah.
I've never had cooked pineapple.
Is anybody else with me on the idea that thank you? Okay, because this
I don't
is
think it should be outlawed, but I don't see a problem with it.
Personally would not.
yeah, okay, alright. So alright, if we ever have pizzas in class, you and I will order together. The rest
You
of us
guys
can
ever
figure out what
tried
we
it
want.
though? Yes.
Huh?
How do you feel
Yes,
about
I
just
have, and it's
pepperoni?
disgusting. I like to spit it back out.
It's really not that bad.
The texture
Huh?
of it too when
Really
it's
not
cooked
that
is
bad.
like
Yeah, I know, it's mush. Blech.
Yeah, she thinks that.
It's good.
So,
I need to try.
Maddie, do you know how many times I've been at people's places and they're like, what kind of pizza you like? I'm like, well, I'm Canadian bacon.
Okay,
They're like,
well, I
okay. And so then I show up, they're like, oh yes, we got a Canadian bacon. I open it up, they're like,
You gotta be more specific.
like this
on
is
that.
Hawaiian. They're like, well, we just figured we'd throw pineapple. I'm like, okay, you just ruined it. And I like try to take it off, but it's still got the juice on there. I'm like,
Pineapple isn't that bad, but it's not like the go-to. Like my go-to is cheese.
okay.
I'm a pepperoni person.
So how many slices of pizza would you like?
How many would
Yeah,
I like?
What would you like? Normal night.
Normal night.
Yeah.
3.
You're getting 3. Okay, that's kind of my go-to. But I've started changing
Take
up.
half that
Instead of right, so that's what I do. My daughter asks, how much pizza would you like? I like 180 degrees. Right? You know, give me 90 degrees.
That's so funny.
Or if it's the one daughter, I'm like, give me 360. That way she's got to go make another one. You know what I mean? You know, I want the whole thing. Right? But suppose that we're getting the Jake special. The Jake special.
It's gotta be pie cut though.
Okay, it is. It's pie cut.
The squares suck.
And Nevaeh, because you're celebrating, okay, you're celebrating your game-winning goal, and she decides to order you pizza, and she brings you 1 degree of pizza. You happy or you sad?
I'm punching.
You're punching. You're angry because you know that 1 degree is simply 1/360th of the circle. That's ridiculous, isn't it?
That's crazy.
Yeah.
But if you think of what 1 degree is, if I ask you what a degree is, you're like, that's a 360th of the circle. That's the only way in which you have the concept of thinking about a degree, right?
Yeah.
Which, by the way, you maybe wonder why 360, like why not 400 or something like that? The base system for numerical systems in Babylonia was, in fact, a base system of 60. Kind of like our base system is 10. Their base system was 60. So they had 6 60s. I think some of it also has to do with the fact that there's 365 days in a year in which the world revolves around the sun. I think that has something to do with it as well. They were the kind of the pioneers of some of our trigonometry. There's a different way to measure angles. You don't have to measure them by degrees. You can measure them in radians. And this kind of gets people angry sometimes. If you were to go over to England, and you wouldn't be driving at 60 miles an hour, would you? You'd be driving
40 kilometers.
probably 100 kilometers per hour, right? Yeah. So kilometers more, okay?
Either way,
So probably going like 100 kilometers per hour. Okay? They do kilometers, we do miles. Actually, the whole world does kilometers, do they not? We're the only ones sticking to miles.
They should conform to us.
That's what people say. We used to say like the trades industry. Well, like people are using like 3/8 inch wrench. No, nobody uses 3/8 inch wrench. You use 10 millimeters. Like even that part of the industry is connected over to millimeters. We are just stuck in our ways when we do it. But anyway, do you agree that like if you were to start like a world government as a whole, that like, come on, the metric system just makes more sense?
Yeah.
Similarly here, degree measure is kind of like the standard thing. Degree measure works in some situations, but for mathematics, radian measurement is the better. It's super useful. In fact, in calculus, you never use degree measure. You only use radian measure. So what is a radian? Well, you see what 1 degree is. What's a radian? A radian comes from the word radius. And I'm going to say what a radian is. And I want you to try to follow along with that, but then I have to explain it to you. 1 radian is the angle formed when the arc that intercepts the angle is the same length as the radius of that circle. So, you tell me, that arc, is that the same length as the radius? Is it shorter than the radius, or is it longer than the radius?
Shorter.
Everybody read shorter? So this angle right here is less than 1 radian. That's less than 1 radian, okay? All right, let's try again. Suppose that I have this part. I'm going to draw it. I'm going to go here, okay? Is the length of the arc longer, shorter, or the same as the blue radius? Longer. So this angle right here is definitely much greater than 1 radian, okay? So who's going to be my volunteer to help me out? All right, Brecken, give it up for Brecken, everybody. Yeah, woo, let's go. No, you stay there. You stay there. So you tell me when to stop. I'm going to start drawing an arc, and you tell me when you feel like my arc is the same length as the radius, okay?
Stop.
What do you guys think? Too long, too short, right? What do you think?
A little long.
A little long.
But it's close.
To be fair, I think he said stop, and I continued on for a little ways. So I'm going to try to back off just a little bit of that. So I'm going to try to like, oh, it just took it all. Oh, that was too bad. I think right about like, is that about where you were?
Yeah.
Yeah, what do you, I think that's pretty good, don't you?
Yeah.
That was the best out of any of the classes. Nice job, Brecken, way to go. Man, you should go for the robotics team. So anyway, so this this is what 1 radian would be. The letter theta is the Greek letter for th. It's the variable that we use to express radian measurement or degree measurement. Theta. Okay? So if that's 1 radian, how many radians do you think fit in a circle? There's 360 degrees that fit in a circle. How many radians do you think fit in a circle? 5?
Too high. 2 times 5 is radius is half the circumference or diameter, right?
What is he saying?
I'm going like 5.
That makes sense.
5 or 6.
5 or 6? Okay, you guys are all right. Brecken is exact in his analysis. Let's show you how he comes up with it. Okay, this would be 2 radians. This would be 3.
6.28-ish.
That would be 4. That would be 5. And that would be 6. There are, in fact, just more than 6 that fit in 360 degrees. Or if you look at it this way, how many fit in 180 degrees? Just a little bit more than 3. Or in other words, 3.14 or pi. So here's what we know. If you have 1 inch, it's equal to 2.54 centimeters. If you have 180 degrees, it's equal to pi or 3.14 radians. That's our conversion. That's what we use to go back and forth.
Wait, can you go back up to like
Yep.
again, please? Thank you.
So from the hope that this is the
Okay.
Is this what we're like memorizing? Aren't we supposed to memorize this?
So as I start laying this out, I cannot, there's some people who sit in class and they just hope to like catch what they can. You want to be present in this class. And especially when we're doing this, you want to see exactly how this goes. You want this to be locked in your brain because you're going to have a quiz next week and this needs to come out like this. And you will be able to do that, but you have to trust me in the process, okay? So we're going to skip the conversion because we're going to run just here short on time, I'm worried. So we're going to lay out parts of the unit circle with more angle measurements than just 0, 90, 180, and 360, and 270. We're going to mark this as 0 degrees. We said 90, and 180, and 270, and 360. Okay, halfway between 0 and 90, 45. And then if I add 45 onto 90, I get 135. If I add 45 onto 180, I get 225.
315.
And then I get 315 degrees and then 360 all the way around. Is everybody okay with those angle measurements? Okay. Now we're going to put the other angles. If I take 90 and divide it up into 3, I get 30 degrees. And then if I go up by 30, I will be at 60, 90, 120, 150, 180, 210, 240, 300, 330. Very good? Everybody see how I came up with those? Those are the most common angles that we like to work with, and they're very special in certain ways. What I'm going to do now for you is I'm going to write the radian measurement in red. So 0 degrees is 0 radians. And 180 degrees was what? pi. So the most important thing you need to know right now is that pi and 180 are the same. From here, you want to be able to do everything that everybody else is doing in class at Jakumi, which is to be able to produce the rest of the radians, okay? If 180 is pi, what is 360? 2 pi. If 180 is pi, then what would 90 be? Half pi, which we write as pi over 2. If 90 is pi over 2, what would 45 be?
Pi over 4.
Pi over 4. If 180 is pi, what would 60 be? How many times does 60 go into 180? 3. So 60 is a third of it, right? So pi over 3. 30 would be 1/6 of that, so pi over 6. Is anyone unclear how I came up with those? From there, the rest can be super easy. And this is what I do in my head all the time when I'm doing the converting. Watch how this happens. I want to figure out 120. Which one of these divides evenly into 120? 30 and
60.
I like to choose the bigger one. How many times does 60 go into 120?
2.
So it's 2 of those. It's 2 pi over 3. Let's go to the 150. Which one of these divides evenly into 150? 30. How many times does it go in? 5. So it's 5 of the pi over 6s. The ones that end in 5 go together, so 45 goes into 135. How many 45s fit in 135? 3 slices of pizza. This is Nevaeh's pizza right here.
Heck yeah.
For the rest of the class, we'll recognize 135 degrees is Nevaeh's pizza, okay? 210, I still do the same thing. What goes into 210?
30.
How many times?
7.
7. So it is 7 pi over 6. When you get the ones that end in 5, you know what's a 45 thing? It's a pizza thing. How many slices of pizza at 225? There's 5 of them. 5 pi over 4. Some people wonder why I talk, like the pizza thing, that's how I thought of it when I was your age. That's how I did it. I was like, okay, it's like pizzas, where does it fit? 240, how about that? Which one goes in 240? 60. 60 how many times? 4. Okay, you said 120. Yeah, that's fine. I like to focus on these as my basis. Wait, 120 maternal side. 60 goes in 4 times, so it's 4 pi over 3. Stay with me, even the bell goes. 270. Which one of these is a little bit trickier?
It's 30.
90.
90 goes in how many times?
3.
3. 3 pi over 2. 300. Which one goes into 300? 60. How many times? 5 pi over 3. Uh-oh, now we got 315. That's a pizza slice. How many slices go in there? There's 7 of them, isn't there? That's 7 slices. 330. What goes into 330?
30.
How many times?
11.
11 pi over 6. That's it. Tomorrow, we're going to get you started on your first assignment and then continue our next lesson. Give you a little bit of time to work in class. Please be ready to bring your stuff together. Everybody say goodbye to Alex. He will not join us tomorrow. He's transferring to third hour.
Bye, Alex.